here. That's not what I want. That was last week's. This is the one I want. There we go. Okay. Hang on. So, this week what I want to talk about is, I want to talk about induction. That's sort of the key point I'd like to discuss. So, what is induction? I think I probably talked about this last week, but induction is a method of proof. It's unrelated to recursion. They're two different things. Okay, recursion is not a method of proof. Want to sort of drill that home because a lot of times people see like we do induction and then we do recursion, so they feel similar, they're similar kind of words. They are not, they're two different things, okay? Recursion is a way that you can define something like a function or a sequence, whereas induction is a way of proving something, okay? It's a technique for proof, just like contradiction, contraposition, proof by cases, right? It's another one of those. We're going to talk about induction. So induction is actually a really broad thing, but I'd like to explain it using dominoes. I always like to try and do this using dominoes. So let's say that you have a bunch of dominoes, and you want, like, let's say that you're a kid, you're playing with dominoes, and you want to make sure that when you knock the dominoes down, they all fall over, right? There's two things that you would have to do to ensure that that's going to happen. The first thing is you have to make sure that they're spaced apart. Right? Anyone who's ever played with dominoes knows, right? If you put them too far apart, then it's going to break, right? So they won't all get knocked down, stuff like that, right? If you put them too close together, I think like it just still doesn't work because the dominoes are heavier, right? Something, I don't know. They have to be spaced apart properly for it to work, right? The second thing is that you have to hit the first one, right? Because if you don't hit the first one, then nothing's going to happen. You're just watching a bunch of dominoes, right? So yeah, two things you have to do. First thing is you have to hit the first one. Second thing is you have to make sure that if one of them's falling, then it's going to hit the next one, right? They're spaced properly apart. So in math, this is the same thing for induction. The first thing is you want to show that P of 0 is true. In other words, that the first domino is going to fall. This is usually called a basis case. The second thing you want to do is you want to show that if P of k is true, that implies that P of k plus 1 is true. So again, in words, this is like if P of some number means that that domino is falling, then this says P of k, so the kth domino is falling. That means that the k plus 1th domino is going to fall. It's going to hit the next one. Yep. Sorry, no, you're good? Okay. All good? This is called the inductive step. So two things you have to show for induction. So induction is actually kind of a bad term for this because there's a bunch of different kinds of induction. And I kind of want to give you a little bit of a survey of a few of them because I think it'll give you a better idea of what we're doing. So this is actually called weak induction because there's a stronger version of it. Yep.
Isn't it?
Strong induction is usually what we call it, but it might be complete. Like there's a possibility. So the thing with complete induction, if that's what it's called, or strong induction, is that if you want to show P of k plus 1, like for the inductive step, you're assuming P of k, and you're assuming P of k minus 1, and you're assuming all the way back to P of 1. So you assume everything before. In other words, you assume all the dominoes before are falling, and that shows that the next one's going to fall. There's cases where you would need to do this, not in this class. In this class, all we'll be dealing with is weak induction. Make sense? There's another idea called, well, a couple ideas called double induction, and I want to show you a video of it.
Sorry, is that the strong induction you were talking about?
Yeah, strong
Can
induction.
you explain it?
Yeah, sure. So strong induction is that, so for weak induction, you just assume the previous one shows the next one. For strong induction, you show that everything before, all of the previous ones, show the next one. So you have to assume all of the previous ones. It's just a little bit strange.
Focus on the last one instead of the first one, or is that the difference?
Well, the difference is that, so in weak induction, you assume this, and you want to show this. In strong induction, you assume this, and you want to show this. So it's assuming everything before, and then showing the next.
So there's no base case in that.
There is a base case still. But then from the base case, you keep adding on, right? Instead of just moving along, you keep adding, right?
In chunks.
Exactly. Awesome. So I'd like to show you a video here, if I can, on, let's see, I'm just going to turn this off for a sec so I can type. Let's see. Let's see. Here's a video I wanted to show specifically. What's his name? Shoot. I have it on my iPad. I should do that. Probably easier. Sorry, folks. This is what I want. That's not what I want. Gotta plug it in first. Okay. Let's wait for this to turn on, if it will. There we go. Cool. Okay. And it might be super loud, so sorry if it's super loud. I'll try to turn it down just a sec, so it doesn't destroy your eardrums. Let's see. Why is it not going? Crap. Shoot. It's black. Why is it black? Ah. I'll just try opening here if it'll do that. And window. This might work. There we go. Sorry. I want you to see this. Not this. I don't care about this app. There we go.
I recently came across this new double domino effect that uses bricks. So I'm on a construction site and there's very tiny, only 48 bricks. We're going to knock them over. It works. Okay.
So here's the initial pick, right? Initial step. You'll notice as we go along, each of these dominoes are lying such that they're lying against the next one, right? And you'll notice when we get to the end, the last domino is going to slide out of it, and it's going to shoot back.
Oh, come on. That one brick. There we go.
So see, the idea is it goes forward, and then it goes backward. So we call this forward-backward induction. So I'll come back here. Maybe I'll switch this back over to here. I think get this cable to work. Hopefully that was worth it. And I'll go back to here. Back here. No, back here. There we go. That's what I want. Cool. Okay. So that was forward-backward induction. So forward-backward induction, the way that this works, first you assume P of 0, so you do your base case, right? Yep.
Is your base case always 0 or do you start?
It could be anything. It's just try and figure out what the first case is going to be. Sometimes it might be 1. There's an example we'll do that might be 7. It'll start at 7. It can start really anywhere. It's just like the first.
Sorry, so like they will give us the domain, and then we just do the first value in the domain, is that how it works?
Exactly, yeah, exactly. So P of 0, check your initial step, could be P of 1, whatever. Then you assume P of K, and you show P of K plus 1. So this is just like basic induction, right? But now we have 2 other steps. So we assume that the last domino, which I'm going to call P of n, or the last case, implies Q of 1, or Q of 0, maybe we'll say, so if we're sticking with 0. In other words, that in this case, it was that the last domino is going to slide out a bit, which is going to sort of set the next domino effect, right? And then you show that Q of K implies Q of K plus 1. So that's your forward-backwards induction. Yeah.
Would you also do something like improve P of K minus or something if you want more P of K works?
Yes. Yeah, that's identical. For any info, that's identical. I'm also going to talk quickly about, so this is forward-backward induction. I'll talk about double induction, which is similar. Double induction is where you have some predicate with 2 inputs, so some function that takes in 2 inputs. First thing you should do is show that P of some base case, say 1, 1 holds. Then you show that P of K and L implies P of K plus 1 with L. So you don't change L, you do change K. The third one, check that P of K and L plus 1 implies P of, P of K and L implies P of K, L plus 1. Does that make sense? There's a couple different kinds of induction. I have a question, which is sort of maybe something to think about. What happens, so with induction, we start at the first case, and then we work our way forwards, right? So we start at the first domino, show that you push the first domino, work your way forwards until you get to the end of the last domino, right? What would happen if we started at the last domino? We said the last domino is falling, and then can we work our way forwards to the first domino? Is that an okay way to do induction?
Yeah.
It's not, oddly enough. And maybe if you want to think of this like logistically, if I know that the last domino is falling, that doesn't mean this one's falling. I could have reached in and just nudged the last domino, right? So you can't do that. And there's actually a term for this kind of proof where you go backwards, and it's called infinite descent. So the idea is, if you have these dominoes, and you know that this one is going to hit this one, well, actually I should phrase this a bit differently. Let's say if this one falls, then this one falls, right? And if you know if this one falls, then this one falls. If this one falls, then this one falls. And you just keep going like this. You end up with a problem because there's not infinitely many dominoes going backwards, right? So you come to the last, right, as the first domino, and you don't know what hit that domino. So you run into an issue. It's called infinite descent. It's actually a proof by contradiction. So it shows that the whole thing's false. You don't have to know any of that. It's just for interest. Let's do some practice. I'm going to give you this question, and I'll give you a few minutes to work on it. It's a proof by induction. And sorry, there's a typo here. This should be non-negative. I wrote negative. It should be non-negative, so 0, 1, 2, 3, and so on. Now you have to stop my recording, so sorry for a second here.